Ever wondered how early neural networks in deep learning work? Welcome to a world where machines learn and evolve, much like us humans. At the heart of this fascinating universe lies the concept of neural networks and deep learning. Neural networks are a captivating subset of machine learning. They are designed to replicate our human brain's functioning, allowing machines to think, learn, and make decisions. Imagine a web of interconnected nodes or neurons, just like the billions of neurons in our brain. These neurons, when arranged in layers, form a structure known as a neural network. Deep learning, on the other hand, takes this concept a step further. It involves feeding these neural networks with heaps of data, allowing them to learn and make accurate predictions. These concepts might seem complex, but once you get the hang of it, they're nothing short of fascinating. Now, let's dive into the specifics of how these early neural networks operate. At the heart of every neural network lies the neuron. Akin to its biological counterpart, this mathematical model receives inputs, processes them, and generates an output. But how does it do that? Let's break it down. Imagine a neuron as a tiny processing unit. It receives numerous inputs, each attached to a weight. The neuron multiplies each input with its corresponding weight, adding them all up along with a bias value. This sum is then passed through an activation function. The activation function is the gatekeeper. It determines whether or not a neuron should be activated, depending on the sum that it receives. It's the activation function that introduces nonlinearity into our model, allowing us to model complex patterns and behaviors. Functions like the sigmoid and the ReLU are commonly used, so the neuron, simple as it may seem, is the basic building block of any neural network. It's the small cog that makes the giant machine of deep learning work. Output. Neurons don't work alone. They're organized into layers. Let's dig a little deeper into this concept. Essentially, a neural network is a series of interconnected layers. These layers are categorized into three types: input, hidden, and output layers. The input layer, as the name suggests, is responsible for receiving information from the outside world. This is where our raw data first enters the neural network. Think of it as the front door, welcoming the data into the system. Then we have the hidden layers. These are the powerhouses of the neural network, where all the actual processing happens. They take the data from the input layer, perform complex computations on it, and pass it on to the next layer. Finally, we have the output layer. This is the grand finale, where the processed data from the hidden layers is converted into a form that we can understand and use. Each layer communicates with the others through a process known as forward propagation. The data flows from the input layer through the hidden layers, and finally to the output layer. These layers work together to process data and produce a result. Now, how do these networks learn? Imagine the neural network as a student attending school for the first time. The teacher, in this scenario, presents the student with various problems and the correct answers. This is akin to feeding the network with training data. The student initially makes a lot of mistakes, but with each mistake, they learn something new and adjust their approach. Similarly, the neural network makes predictions based on the weights assigned to its neurons. When the network's prediction is off, the error is calculated. This error then flows backward through the network, a process known as backpropagation. Each neuron's weight is adjusted slightly in line with how much it contributed to the overall error. This iterative process of forward prediction and backward error correction continues until the network's predictions become more accurate. This, in essence, is how a neural network learns. It's a process of constant refinement and adjustment. Through training, a neural network learns to make accurate predictions. So, what did we learn about early neural networks in deep learning? We've journeyed through the fascinating world of early neural networks, starting with the neuron. This basic building block, modeled after our brain's own neural cells, is the heart of any neural network. It's the neuron's job to take in data, perform computations, and output results. From there, we discovered how these neurons are organized into layers. Each layer has a particular function and complexity, starting from the input layer, passing through hidden layers, and culminating at the output layer. This structure allows for the processing of complex data in a systematic and hierarchical way. And finally, we dove into the training of a neural network. Through a process of trial and error, the network learns from its mistakes and adjusts its weights, improving its performance over time. Understanding these early neural networks is the first step towards grasping the complex world of deep learning. So keep exploring and keep learning.